This is SpaceTime Series 24, Episode 77. Coming up on SpaceTime, the Earth's cycle of geologic activity. New studies suggest Asteroid Psyche probably isn't going to be what scientists are expecting. And solving at least one of the mysteries of Martian methane. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims geologic activity on planet Earth appears to follow a 27.5 million year cycle, giving the planet a sort of pulse. The findings, reported in the journal Geoscience Frontiers, contradicts the accepted idea that geological events are random over time. The study's lead author, Michael Rampino from New York University, says his research provides statistical evidence for a common cycle, suggesting that these geologic events are correlated and not random. Over the past 5 decades, scientists have proposed cycles for major geological events, including volcanic activity and mass extinctions, ranging from roughly 26 to 36 million years. But early work on these correlations in the geological record was hampered by limitations in the age dating of geological events, which prevented scientists from conducting quantitative investigations. However, in recent times, there have been significant improvements in radioisotopic dating techniques, and that's led to changes in the geologic timescale, which in turn has led to new data on the timing of past events. Using the latest age dating data available, Rampino and colleagues compiled updated records of major geological events over the past 260 million years, and then conducted new analyses. The authors analysed the ages of 89 well-dated major geological events over the past 260 million years. These events include both marine and land extinctions, major volcanic outpourings of lava known as flood basalt eruptions, events when oceans were depleted of oxygen, sea level fluctuations, and changes or the reorganisation of Earth's tectonic plates. They found that these global geological events are generally clustered at 10 different time points over 260 million years, grouped in peaks or pulses roughly 27.5 million years apart. The most recent cluster of geologic events was approximately 7 million years ago, and that suggested the next pulse of major geological activity is more than 20 million years into the future. The authors suggest that these pulses may be a function of cycles of activity in the Earth's interior, geophysical processes related to the dynamics of plate tectonics and climate, or similar cycles in Earth's orbit in space, which might also be pacing these events. This is SpaceTime. Still to come, new studies suggest Asteroid Psyche probably isn't going to be what scientists are expecting, and solving at least one of the mysteries of Martian methane. All that and more still to come on SpaceTime. The intensely studied metallic asteroid known as 16 Psyche has long been considered to be the exposed iron core of a differentiated small planet that was smashed apart during the early days of our solar system. But a new study reported in the Planetary Science Journal suggests instead that the 253 kilometre wide asteroid might actually be a rubble pile asteroid rather than a planetary core. Scientists are interested in 16 Psyche because if its presumed origins are true, it would provide an opportunity to study an exposed planetary core up close. Psyche orbits the Sun in the main asteroid belt between Mars and Jupiter, around 3 times further out from the Sun than Earth. The new study's lead author, David Cantillo from the University of Arizona, says his observations suggest that 16 Psyche is 82.5% metal, 7% low iron pyroxene, and 10.5% carbonaceous chondrite that was likely delivered by impacts from other asteroids. Cantillo and colleagues estimate that the asteroid's bulk density or porosity, which refers to how much empty space is found within the asteroid, is somewhere around 35%. Now, these estimates are very different from past analyses of Psyche's composition, which have led researchers to estimate that it could contain as much as 95% metal and be much, much denser. Cantillo says the drop in metallic content and bulk density is interesting because it shows that 16 Psyche is far more modified than had previously been thought. Rather than being the intact exposed core of an early planet, Psyche may actually be closer to a rubble pile. In fact, very similar to the asteroid Bennu. The University of Arizona leads the science team for NASA's OSIRIS-REx mission, which retrieved a sample of Bennu's surface and is now making its way back to Earth. Discovered back in 1852, scientists estimate that Psyche probably contains about 1% of all the main asteroid belt's material. Having a lower metallic content than once thought means that the asteroid could have been exposed to collisions with other asteroids containing carbonaceous chondrites, which were then deposited as a surface layer which is being detected. NASA's Dawn spacecraft observed a similar occurrence when it was studying the asteroid Vesta. Meanwhile, the most recently studied asteroid Bennu does contain a lot of carbonaceous chondrite material, and it has a porosity of over 50%, which is a classic characteristic of a rubble pile asteroid. Of course, such high porosity is common for relatively small and low mass objects such as Bennu. That's because a weak gravitational field prevents an object's rocks and boulders from being packed tightly together. But for an object the size of Psyche to be so porous is unexpected. Past estimates of Psyche's composition were done by analysing the sunlight reflected off its surface, and the spectra of that light matched that of other metallic objects. Cantillo and colleagues instead used a different approach. They recreated Psyche's regolith, or loose rocky surface material, by mixing different materials in a lab and then analysing the light patterns until they matched the telescope observations of the asteroid. They also believed that the carbonaceous material on Psyche's surface could be rich in water, and so they plan to merge data from ground-based telescopes and spacecraft missions to other asteroids to help determine the amount of water present. Meanwhile, NASA may be able to resolve the issue in the not-too-distant future. They're planning to launch the Psyche mission to the asteroid next year, aiming to arrive around the space rock in 2026. To find out more, Andrew Dunkley is speaking with astronomer Professor Fred Watson.
Now, asteroid 16 Psyche, it's starting to look like it is not what we thought it was. What did we think it was?
Well, from my personal experience, I've known about 16 Psyche since I was a master's student, because it's one of the asteroids that I used in when I was writing my master's thesis on asteroid orbit. So it's an old friend, is 16 Psyche, but it's also famous as an asteroid because for some years now, astronomers have thought that what we're seeing in this asteroid is the metal core of a protoplanet. And a protoplanet is what planets grow out of as they're being formed. And this is a protoplanet that's had its rocky mantle knocked off, leaving behind just the metal core, because we know it's highly metallic. We can tell from measurements that its surface is very, very metallic. It's one of the bigger asteroids, not a small object. And indeed, all the speculation that we can talk about now is going to be set to rest in, I think, about 4 years, because there's a mission going to 16 Psyche. It's a NASA mission. It's called Psyche. And by the way, Psyche is the Greek goddess of the soul. It's a very nice name. But the thinking now, which comes from research in the University of Arizona, is that its density is too low for it to be the solid metal core of a protoplanet. And what they're saying is, it's, in fact, they're turning it round. They're talking about porosity. Porosity is, if you think of something like a piece of pumice, the porosity is the amount of empty space that's within it. And the porosity of 16 Psyche has now been measured to be about 35%, which means that 35% of its bulk is empty space. And that doesn't really tally with the idea of a metallic core of a protoplanet, unless it's kind of more solid in the middle and it's just a bit frothy on the outside, which I guess is a possibility. But that sort of detail is probably not something we'll really get to see until the Psyche spacecraft gets there. It will go into orbit around Psyche. I can't remember when, but it's in a few years' time, and hopefully will give us much more detail. In fact, we'll get a very precise measurement of its density from that, and as well as much else besides. So yeah, watch this space is the answer there. It's a interesting story.
Have they been able to compare it to other objects that
Yes,
might be
they
similar?
have. Yeah, that's a good question. Thank you for raising that, because there's been a suggestion that it might actually be a rubble pile. And we know of many rubble piles. In fact, two of them have been visited by a spacecraft recently, Bennu and Ryugu, the other one, Bennu and Ryugu.
That's it.
They are, in fact, spacecraft are on their way back to Earth with samples from both those asteroids. They're rubble piles. They're just debris that's bound together quite loosely. But they have porosities more than 50%, which says that half of the asteroid is empty space inside it. Psyche is not at that level, but it does make them wonder if maybe what we're seeing is perhaps the metallic core of a protoplanet as was originally thought, but maybe with a rubble pile on top of it or something like that. It's, very interesting stuff.
Can't wait for those samples to come back, because it'll just add more pieces to the puzzle that is our solar system and the universe. And it makes me wonder if aliens ever sent a probe down to Earth and took samples back, they'd probably end up with an old KFC box and a hamburger wrapper. So hopefully we won't be disappointed.
Maybe the odd V8 engine or something that's been thrown away because it's worn out.
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. Still to come, solving one mystery of Martian methane and more power to the International Space Station. All that and more still to come on Space Time. One of the big mysteries of Mars is, why do some science instruments detect methane on the red planet while others don't? Reports of methane detections on Mars have captivated scientists for years. Here on Earth, most methane is produced by microbes, often inside the intestinal tract of livestock digesting plants. So methane on Mars could well suggest Martian microbes, and that's what scientists are excited about. However, before you get too excited, methane could also be produced through geological processes involving interactions between rocks, water and heat. So, no biology needed. And that means no life on Mars. But before identifying the source of methane on Mars, scientists first need to settle a more basic question that's been gnawing away at them. Why is it some instruments detect this gas while others don't? For example, NASA's Mars Curiosity rover has repeatedly detected methane right above the surface of Gale Crater using its tunable laser spectrometer. But the European Space Agency's ExoMars Trace Gas Orbiter hasn't been able to detect any methane higher in the Martian atmosphere. Mars Curiosity rover scientist Chris Webster from NASA's Jet Propulsion Laboratory in Pasadena, California, says that when the Trace Gas Orbiter arrived at Mars in 2016, he was expecting the orbiter to report small amounts of methane everywhere in the Martian atmosphere. But the Trace Gas Orbiter has measured less than 1 part per billion in volume of methane on average. That's equivalent to about a pinch of salt diluted in an Olympic-sized swimming pool. The European findings are quite shocking. ExoMars Trace Gas Orbiter was designed to be the gold standard for measuring methane and other gases over the entire planet. At the same time, Curiosity's tunable laser spectrometer is so precise, it's even used for early warning fire detection on the International Space Station and for tracking oxygen levels in astronaut suits during EVAs. It's also been licensed for use in power plants, on oil pipelines, and on fighter aircraft where pilots use it to monitor oxygen and carbon dioxide levels in their face masks. Webster and colleagues were surprised by the European orbiter's findings and set out to scrutinise the Curiosity measurements on Mars. See, some experts have suggested that maybe the rover itself was somehow causing the release of the gas. So Webster and colleagues looked at correlations with the direction the rover was facing, the ground, the crushing of rocks, and even the amount of wear and tear on the rover's 6 wheels. Webster says after looking at every little detail to make sure those measurements were correct, he's now certain that they are. Webster and his team have now reported their results in the Astronomy and Astrophysical Journal. But while they were working to confirm their methane detections, another member of Curiosity's team, planetary scientist John Moores from York University in Toronto, was looking at Gale Crater's wind patterns, and he hypothesized that the discrepancy between methane measurements could come down to the time of the day they were taken. See, because it needs a lot of power, Curiosity spectrometers usually only operated at night, when no other Curiosity instruments are working. And the thing is, the Martian atmosphere is fairly calm at night. So, any methane seeping up from the ground would build up near the surface at night, where Curiosity can easily detect it. On the other hand, Trace Gas Orbiter requires sunlight to pinpoint methane, about 5 kilometres above the surface. And any atmosphere near the planet's surface would go through a cycle during the day, with heat from the sun churning the atmosphere as warm air rises and cool air sinks. So the methane that's confined near the surface at night would instead be mixed into the broader atmosphere during the day, which would dilute it to virtually undetectable levels. Therefore, an orbiting instrument would have difficulty detecting anything. To test Moore's hypothesis, Curiosity mission managers collected the first high-precision daytime measurements. They measured methane continuously over a full Martian day. Going even further, bracketing one Martian nighttime measurement with 2 Martian daytime ones. With each experiment, they sucked in Martian air for 2 hours, continually removing the carbon dioxide, which makes up 95% of the planet's atmosphere. This left a concentrated sample of methane which was easily measured by an infrared laser. And the readings confirm that methane levels do drop to near zero during the day and go up at night, just as predicted. While the study suggests that methane concentrations rise and fall throughout the day on the surface of Gale Crater, scientists have yet to solve the global methane puzzle at Mars. See, methane's a stable molecule which should last in Mars's atmosphere for around 300 years before getting torn apart by solar radiation. If methane is consistently seeping up from all the small craters on the red planet, which scientists suspect is likely given that Gale Crater doesn't seem to be geologically unique, enough of it should be accumulating in the atmosphere for the Trace Gas Orbiter to detect it. So that means something else must be destroying methane in less than 300 years. Experiments are now underway to test whether very low-level electric discharges induced by dust in the Martian atmosphere could be destroying the methane, or whether abundant oxygen on the Martian surface is quickly destroying the methane before it can reach the upper atmosphere. This is SpaceTime. Still to come. More power for the International Space Station, and later in the science report, new computer modelling shows that the COVID-19 virus is unusually ideally adapted specifically to infect humans. All that and more still to come on SpaceTime. Astronauts have successfully installed a new pair of solar panels on the International Space Station. The installation took 3 extravehicular activities or spacewalks in just over a week to complete. The new panels, which were set up aboard a Dragon cargo ship last month, will supplement the orbiting outpost's existing massive solar arrays, providing enough energy to keep the space station running until the end of the decade. The project was expected to take just 2 spacewalks to complete, but a control panel display problem and a fleeting pressure spike in the cooling system of one of the spacesuits hampered work during the first EVA. And there were also issues with the mounting bracket for the new solar arrays, which took time to resolve. All this meant that the first of the 19-metre solar panels needed a second spacewalk before astronauts were set to unfurl it. And then a third spacewalk was needed to install and extend the second solar panel. As a precaution, most of the work was undertaken on the night side of the Earth, so the solar panels didn't start soaking up sunlight and generating electricity while the astronauts were still working on the power grid. Thanks to new materials and technology, the 2 new solar panels are generating more power than the station's original 20-year-old solar arrays. 4 more of the new panels will be installed on the space station in the coming year. Meanwhile, 2 Russian cosmonauts carried out their own spacewalk aboard the orbiting outpost to prepare for the arrival of a new Russian module. The work involved getting things ready for the undocking of the Pirs docking module, which will be replaced later this year by the new Nauka multi-purpose science laboratory. The preliminary work included replacing fluid flow regulators and relocating biological and material science samples on the exterior of the Russian module. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. New computer modelling of the SARS-CoV-2 virus, which causes COVID-19, has discovered that the virus is most ideally adapted specifically to infect humans, rather than other animals such as bats or pangolins. The findings, published in the journal Scientific Reports, are raising new questions about the true origin of the deadly pandemic, underlining the possibility that a virology lab origin cannot be ruled out. A new study by scientists from Flinders University in Adelaide and Melbourne's La Trobe University used genomic data from 12 animal species to painstakingly build computer models of the key ACE2 protein receptors for each species. These models were then used to calculate the strength of binding of the SARS-CoV-2 spike protein to each species' ACE2 receptor. The results showed that SARS-CoV-2 bound to ACE2 receptors on human cells far more tightly than any other tested animal species, including bats and pangolins. So, if one of the animal species tested was the origin, it would normally be expected to show the highest binding to the virus. But instead, it was humans which showed the strongest spike binding. And that's consistent with people's high susceptibility to the virus. And that also raises significant questions about where the virus really came from. The World Health Organization now estimates more than 8 million people have been killed by the COVID-19 coronavirus, including over 4 million confirmed fatalities. The WHO also says more than 184 million people have now been infected with COVID-19 since the deadly disease first spread out of Wuhan, China. Scientists believe they've discovered a new human species that could be Homo sapiens' closest relative yet. A report in the journal Innovation suggests that the fossil is that of a man about 50 years old, belonging to a new species of human called Homo longi or dragon man, which is closer to Homo sapiens than Neanderthal. Researchers found a skull that could hold a brain comparable in size to that of modern humans, but with larger, almost square eye sockets, thicker brow ridges, a wide mouth and oversized teeth. Geochemical analysis suggests that the near-perfectly preserved fossil, known as the Harbin cranium, dates back some 146,000 years, placing it in the Middle Pleistocene. And that suggests that this new species and modern humans could have encountered each other during this era. A new study claims some 267 million people worldwide are now living on land at risk from sea level rise. The findings, reported in the journal Nature Communications, used satellite technology to analyse the global terrain to find regions that are less than 2 metres above sea level. The authors found that in 2020 there were some 267 million people living less than 2 metres above sea level, where severe storms and flooding could put their homes at risk. The analysis also found that 62% of the most at-risk land was located in the tropics, with Indonesia being the most at risk. The authors predicted by the year 2100, the number of people at risk will increase to 410 million, with 72% of those living in the tropics. Bit of good news now, and a new study has found that eating a little milk chocolate every day may actually help the body burn fat and decrease blood sugar levels. The findings, reported in the Phase B journal, may sound like a recipe for weight gain, but researchers found eating a concentrated amount of chocolate during a narrow window of time did not lead to weight gain. To find out about the effects of eating milk chocolate at different times of the day, the researchers conducted a randomized controlled crossover trial of 19 postmenopausal women. The subjects were each asked to consume either 100 grams of chocolate in the morning within 1 hour of waking, or at night around an hour before bedtime. They found that compared to no chocolate intake at all, eating a small amount of chocolate in the morning or the evening can influence hunger and appetite, microbiota composition, sleep, and physiological mechanisms involved in the regulation of body weight. Researchers say a high intake of chocolate during the morning hours could help burn fat and reduce blood glucose levels. while night chocolate consumption altered next morning resting and exercise metabolism. Microsoft has shown off its new Windows 11 operating system, which will arrive later this year as a free upgrade to Windows 10. But is it a real upgrade or simply a facelift? With all the details, we're joined by technology editor Alex Zaharov-Reutt from ITWire.com.
Well, it's got a nicer set of desktop wallpapers. It's got a new set of centered icons at the bottom of the screen with the start menu on the left-hand side of those, which also is a simplified start menu. The live tiles have been taken away, but widgets are in this new section on the taskbar. You can click in from the left-hand side, you can bring on the widgets and see news, sport, weather, and a bunch of different widgets that you'd expect. And so this new design and features that enable you to run Android apps from the Amazon App Store, notably not the Google Play Store, but still a selection of Android apps, plus new ways to snap your windows. When normally you can snap a window to the side and you can see which one to snap to the left, but on a big enough screen you can have 3 apps snapped open, or you can have 2. And there's a whole stack of cool little things: Xbox games integration, the ability to access much faster forms of storage than previous versions. But there's also a downside to Windows 11 in that not everybody will be able to upgrade. You need an 8th generation Intel Core i-Series CPU, a 3579 or better processor. There's also some select Atoms and Celeron, Pentium Silver and Pentium Gold. Obviously not the really old ones, but recent ones that are able to be compatible with Windows 11. So that means people with older Intel processors, the Core i7 7th generation and down, can't upgrade to Windows 11, even though the decision seems to be arbitrary, although it is being spun as being for security, which is a legitimate thing to want to achieve.
Is it a free upgrade, or how does all that work?
Well, it's a free upgrade, but it's a free upgrade only for those qualifying computers. Now, there has been an outcry from people saying, well, my computer's perfectly good with an i5 or an i7 with 64 gig of RAM and SSDs and all the rest, and it's just a shame I can't use it. And personally, I have a Samsung Galaxy Book 12 Core i5 7th generation processor, and it ticks every other box of TPM 2.0 and minimum amount of storage that it requires, and 4 gigabytes of RAM that it requires as a minimum, and these other things. Originally, it said a 1 gigahertz processor that was 64-bit, but it has now been clarified to a compatible one. And presumably, much of the world's 1.3 billion PC users, a lot of them would be on older equipment. Now, look, Microsoft is still allowing you to run Windows 10 until 2025, October the 24th, 2025. That's the cutoff date. So you're not being abandoned by Microsoft. Windows 10 will continue being supported. But if you want to use Windows 11, you either have to have a qualifying PC or you have to buy a new PC. So there's some cynicism that this is just a big ploy to get everyone to buy new PCs. And in the middle of a pandemic and the climate change concerns and building all this extra stuff and shipping it and all the electricity to power it, and then potential e-waste.
People click on their start button, they'll actually see a Windows 11 introduction there. That was put there automatically by Microsoft. So,
well, as a Mac user, I don't use Windows as much as I should. Well, no, but I do have my Samsung Galaxy 12, which I've been wanting to load version 11 beta, but they won't even let you run it on a machine that doesn't match the minimum specs. But the developer version, it can run on machines that don't match the specs. But the catch is that if your developer machine doesn't meet the match specs, you'll be able to run it in the interim. But as soon as Windows 11 is launched, you will have to go back to Windows 10. They won't give you a free pass to get into Windows 11. But as a developer, you probably want to test for it and not have to buy a whole new machine to do that. And look, there'll be plenty of new Windows 11 machines for Christmas. Microsoft said the holiday season, people are pointing towards October, end of October, which is sort of traditionally when they have the end of year sales, shopping, Christmas, buying, holiday season revving up, and there'll be tons of Windows 11 computers, and all the computers are on sale now that can be. I'm sure all the websites say Windows 11 compatible, free upgrade.
That's Alex Zaharov-Reutt from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.